okay, that we saw before in Unit 2 when we talked about the exponential function, okay, e to the x, okay. So where does this number e come from? Okay, what was the original idea? Well, it was discovered or first described by a guy named Jacob Bernoulli in 1683. Okay, so it was a long time ago. And Jacob was a member of the Bernoulli family, which is famous in the world of mathematics because many of its members were famous mathematicians. Like there was Jacob, you had Johann, you have Daniel. Many of them made very important contributions to mathematics. Okay, so the idea of Jacob, he was studying a problem in economics about compound interest. Okay, so he said, well, suppose I have an account in the bank with €1. Okay, it wasn't €1 because there were not euros back then, but you get the meaning. €1, and a bank after 1 year or 12 months gives me 100% of interest. Okay, so I get €2, right? Now suppose instead of waiting 12 months to get my money back, I get it after 6 months. Okay, so I get 50% of the interest, and 50% of back of 1% is €1.5, right? And then say, well, after 6 months I get back again 50% of my interest, and so you get your money plus 50%, and 50% of, so 150% of this is €2.25, right? And so you can see that it's more money than before. So if you, instead of waiting 1 year to get your interest, you cut it to half of a year, you get more money. Now if you do it, for instance, in 5 times, okay, 1, 2, 3, 4, 5 times, okay, you get 1 over, so 20% of interest each time, and you get it, so it's 20%, and then 30%, and then 20%, 20%, right? And finally 20%, you get €2.488. Okay, so it's clearly more. Okay, so the idea is I have my original money 1, and what I get in the end is 1 plus, and then 1 over n to the n euros back. Okay, where n is the number of times you collect. Okay, number of times you divide, number of divisions. Okay, of divisions of this year, right? So for instance, in this case, you have 1 plus 1 over 2 square, and so this is 1 plus 1 over 2 squared, yeah, so this is 2.25. Is this true? Yes, sorry. So, because, yeah, this is 3 halves, this is 1.5 squared, this is 2.25, right? So, as he said, well, what happens if I keep increasing n, right? So, I take greater and greater and greater numbers of n. Okay, well, you can see what the values look like. Okay, if you go 10 divisions is 2.59, 2.7, 2.71, 2.718. So it's increasing. It's an increasing sequence. Okay, you can think of it. This is a sequence, and it's increasing. Okay, and it's easy to prove that this sequence is bounded. It's actually bounded by 3, for instance. This is smaller than 3 for all n. Okay, it's easy. You can prove it using induction really easily. Now, if you have this proof, this is monotonically increasing. It's also easy to prove. Then this sequence will have a limit, as we have said before. Okay. Well, this limit is this number, that it's an irrational number, and it's also a transcendent number. It's called transcendent. Okay. This means that there is no equation, an algebraic equation like, you know, x squared plus 5x, something like that. There's no equation like this that gives you e as a result. Okay, so e only comes from this kind of expression.